Question 4. When substances P and Q react together to form substance R, an equilibrium is established according to the equation. So P plus Q makes 2 moles of R. The equilibrium constant expression Kc is R squared divided by concentration of P divided by concentration of Q. So that's fairly standard from this equation, where you've got the concentration of the product raised to the number of moles, which is 2, divided by the concentration of P and divided by the concentration of Q from the left-hand side as the reactants. 1 mole of P and 1 mole of Q were mixed in a container with volume 1 decimeter cubed. At equilibrium, X moles of P had reacted. The amount in moles of each P and Q at equilibrium is 1 minus X. Deduce in terms of X the amount in moles of R in the equilibrium mixture. Well, you always set it out as a table like this to start off with. So P plus Q makes 2R. So at the start, you've always got to lay it out like this. This simplifies things. So at the start, there's 1 mole of P and 1 mole of Q, and there's no R. There's no mention of R at the beginning. You won't have made any R right at the beginning because P and Q have not had a chance to react. It says at equilibrium, X moles of P had reacted. So if X moles of P have reacted, then it must mean that Q moles of P have reacted, because 1 mole of P reacts with 1 mole of Q. So X moles of P have reacted, X moles of Q have reacted, and when 1 mole of P reacts, then 2 moles of R have reacted. So if X moles of P have reacted, then 2 moles of X of R have been made, rather. So X moles of P used up, X moles of Q used up because 1 reacts with 1, and 1 mole of P makes 2 moles of R, so X moles of P have been used up to make 2 X moles of R. So what's left at equilibrium for this equilibrium expression? So at the start there was 1 mole, take away X that's been used up, 1 minus X, Q 1 minus X, and R as there's 2x at equilibrium because there's nothing to start with and we've made 2x. So I can replace all of these values in here. So first of all, these are moles, by the way, and I've got to divide by volume, but the volume's 1. So these numbers of moles divided by 1, something divided by 1 is itself. So my Kc, which is 3.6, equals concentration of R squared, or the concentration of R is 2x squared, divided by the concentration of P, divided by the concentration of Q. So it's 1 minus X multiplied by 1 minus X, or 1 minus X squared. Now if I square root everything, square root the 3.6, square root the 2x squared, and square root the 1 minus X squared, so square root everything, square root of 3.6 is 1.9, square root of 2x squared is just 2x, square root of 1 minus X squared is just 1 minus X, multiply both sides by 1 minus X, so 1.9 multiplied by 1 minus X is 2x. Expand these brackets, 1.9 times 1 is 1.9, 1.9 times X is 1.9X, so it's 1.9 minus 1.9X equals 2X. Take the 1.9X across the other side, 1.9 equals 3.9X, X equals 1.9 divided by, that should say 3.9, equals 0.49. 0.49, so if X equals 0.49, deduce R equals 2x, so R is 2 multiplied by 0.49 divided by this number of moles divided by the concentration. Moles divided by concentration is the volume, rather. Moles divided by the volume is 1 decimeter cubed, so number of moles 2 times 0.49 divided by the volume gives the concentration of R, 0.98 mole per decimeter cubed.